Well, welcome to Using Scientific Formulas, Unlocking the Solutions. My name is Julie Ray, and I am happy to be here talking to you about this. I do realize that I need to put my screen on full screen, and I can't because this is in the way. Let me go up here. Nope. Oh, you would think I've never done this before, and that's just wrong. I totally have. And where is this? Let me go back. There we go. That's where it is. Now I'm ready to start. Okay, welcome to Using Scientific Formulas. There are just 3 basic steps that you need to know when you're working with formulas. And the first is that you write down the formula, then you substitute unknown values, and you solve for the unknowns. So 3 easy steps. Most of the time, you are given the formula right in the problem, but if you are not, frequently you will have a formula sheet to use if you're taking a test. So make sure you make use of that, and following these easy steps will help you solve those problems. Let's work our way through a couple. The first thing we're going to look at is distance problems. These are problems that you see both in science and in algebra. It's a very simple formula. The distance equals the rate times the time. Well, that makes sense. How far you go depends on your speed and the amount of time you travel. So this spring, while we've been on lockdown, my husband and I have been taking walks, and we figured out that our rate is 20 minutes a mile. So if we walk for an hour, that's 3 blocks of 20 minutes. So 3 times 1 mile means that if we walk an hour, we're walking 3 miles. So we did that every day and eventually made our way completely around the metro parks during our shutdown. So essentially, that makes sense. Distance equals rate times time. How far you go depends on your speed and the amount of time you travel. Let's look at a simple problem here. So how far will I travel if I drive 65 miles an hour for 3 hours? So it's asking me how far. I know that's a distance problem. What is the formula for finding distance? Distance equals rate times time. Now I'm going to substitute in the known values. So it's asking me how far. That means that distance is going to be my unknown. Then I should be able to substitute in a rate and a time. Here's my rate, 65 miles an hour. That means I'm going 65 miles in every hour. So for 1 hour, that's a rate. 65 over 1 is how I'm going to write that as a fraction. And then my time is 3 hours. So in place of the time, I'm going to substitute in 3. This is what it looks like. Distance, my unknown, is equal to my rate of 65 miles for 1 hour. 65 miles per hour. You can see that that is a fraction. It is also called a ratio because it is 65 to 1. Now, I have also written this 3 hours as a ratio, 3 to 1. So to make it easy to multiply these 2 fractions. And I want to make sure that you understand that the rate is a fraction even if it has a denominator of 1, that is still a fraction. And many times we don't even write it like that. We just write it simply as 65 times 3. But sometimes it's important to understand that this is a fraction, and we'll see why in a few minutes. So I want to get you in the habit of thinking of this 65 miles per hour as a ratio that we write as a fraction. And then all we do is solve. And we know if we have two fractions and we're multiplying, then we multiply numerator times numerator and denominator times denominator. And that looks like 65 times 3 is 195. 1 times 1 is 1. Now we can see that this is still written as a fraction. And we can either think of this as simplifying this fraction, 195 over 1, or we can think of it as a division problem, 195 divided by 1. Either way, we're going to simplify this to 195, or we're going to know that 195 divided by 1 is 195. And so our distance will equal 195 miles. All right, let's look at a different example. How far will I travel if I drive 65 miles every 2 hours and I drive for 3 hours? So what's our formula? Distance equals rate times time. It's asking me how far, so I know distance is going to be my unknown. And then my rate, I'm looking for a ratio, 65 miles every 2 hours. So this fraction is going to be 65 miles over 2 hours. And I drive for 3 hours. My time is going to be 3. So what does that look like if we write it as an equation? Here's my unknown, distance equals, here's my ratio, 65 over 2. I drive 65 miles every 2 hours. And then times my time. And I'm writing it again as a ratio to help us see how to multiply these ratios or fractions. And when I simplify that expression, this here on the right-hand side, I got distance equals 65 times 3 is 195. 2 times 1 is 2. And now I have a division problem. 195 divided by 2, which if I simplify, leaves me with 97.5 miles. So how far will I travel if I drive 65 miles every 2 hours and I drive for 3 hours? I will go 97.5 miles. Now, another way you might have thought about that is, well, I drive 2 hours, I get 65 miles, and then I drive another hour, so I need to half that 65 and add it, and you would be right. You would get the exact same answer. Another way of thinking about it, that's using logic, but in reality, what you're doing is saying rate times time and simplify. Now, how long did I travel if I drive 45 miles per hour and I drive 180 miles? Well, here's a length of distance, a unit of distance here, and here's a rate, and it's asking me how long, referring to time. So again, this is a distance equals rate times time problem. But what is it that I don't know this time? It gives me the total distance. So distance is not my unknown. It gives me the rate, 45 miles per hour. So rate is not my unknown. It's asking me how long. So what is the length of time that I drive if I drive 45 miles per hour and I drive 180 miles? How long will I be on the road? So we know our formula. We substitute in what we know. Distance is 180, rate is 45, and time is my unknown. And that looks like this. 180 equals my rate, 45 over 1 times time. Now, how do I solve for this variable when it's over here and not by itself? This is where algebra comes in to solving these. If you are not familiar with solving one-step equations, there is a great video. So go to the saved videos, the video library, and you can get some lessons in that. But I will show you, talk you through it now. If you still don't understand, do go to the video and watch it because that'll help you in solving these problems. So if I know that these two, this variable and this constant are connected by multiplication, then what I want to do is the opposite of that so that I undo that multiplication. That way, I'll be moving this 45 over to the other side of the equal sign. I will have still an equivalent equation. As long as I do the same thing to both sides of the equation, the result will be an equivalent equation. That means I will not have changed the value, but I will have isolated this variable so I can say, what does t equal by itself? So what I'm going to do is divide both sides of this equation by 45. This 180 equals 45t. I simplified this 45 over 1 to be 45t. Now I'm going to divide both sides by 45. And with any luck, I'll have an answer there. 180 divided by 45 is 4. And if I divide 45t by 45, I will have a result of 1. So 1t, or the time in this problem, is equal to 4 hours. Does that make sense? If I multiply 45 miles per hour times 4 hours, do I get 180? The answer is yes. So here's another problem. What is my speed if I drive 141 miles in 3 hours? So it's asking me or telling me speed, distance, time. It's a distance equals rate times time problem. Let's see. What is it that I know? Do I know my distance? I sure do, 141 miles. Do I know my rate? No, it is asking me my speed, which if you think about speed as I'm saying I'm driving, so we assume I'm driving a car, miles per hour is how you designate speed. So that's my rate. Speed is my rate, so that's my unknown. And then I've got my favorite 3 hours again. So my time is 3 hours. When we substitute in, it looks like this. Distance 141 equals my rate, which I don't know, times my time, 3. How do I solve for my rate? I know that these two are multiplied, so to undo that multiplication, I'm going to divide both sides by 3. And let's see what my answer is. Here's I showed you what this looks like. I'm going to divide this side by 3. So I know 3 divided by 3 is 1. So now I'm going to have just 1 R over here. And then 141 divided by 3. If I do that calculation, my answer is 47. My rate is 47. So again, if I think of my units, what unit makes sense for a rate? Miles per hour. And look what I've divided here. Miles, 141 miles divided by hours. So my rate is 47 miles per hour. Okay, go back one more time. So there's the 47 miles per hour is the answer. These are all distance problems. Notice that each time we were finding one of these components, and it is the same process. We're either going to multiply rate times time to find the distance, or we're going to divide distance by rate to find the time, or we're going to divide distance by time to find the rate. Now, here's a different kind of problem that you frequently see in science tests, and they are about Newton's second law, which just says the more mass an object has, the greater the force is needed to accelerate it, which totally makes sense. The words might seem a little confusing, but we all know it's much easier to push an empty shopping cart than it is to push a full one. And if you have to push it across a snowy parking lot full of ice chunks, it's harder still. But this law can be represented by a formula. And the formula is simply force equals mass times acceleration. So my force depends on how much mass an object has and how fast I want to move it, or how much I want it to move, how far I want it to go. So another important thing to note is that force is measured in a unit called newtons. And they are, of course, named after Sir Isaac Newton, who came up with the three laws of forces and motions. So force is measured in newtons, represented by the capital letter N. 1 newton is the force needed to accelerate 1 kilogram of mass at the rate of 1 meter per second squared in the direction of the applied force. Again, that seems like a lot of words and a little confusing, but essentially what it's saying is that this force, measured in newtons, is equal to how much the object weighs, whether your shopping cart is full or empty, and how fast you want it to go, as measured in meters per second squared. So how fast you want it to go over the amount of time. So pushing it, making it travel 2 meters in a minute takes a less force than if you wanted to go 2 meters in a second. And all of that makes perfect sense. Seems a little bit more confusing when we put it in an equation form, but we all understand these laws. We know it, we operate with them every single day. So let's look at a simple problem. How much force is needed to move a car weighing 1,100 kilograms at a rate of 4 meters per second squared? So we know that our formula, we're writing it down, force equals mass times the acceleration. We know what the mass is, 1,100 kilograms. And the rate is 4 meters per second squared. So we just substitute in. We're looking for force, so that stays our unknown. Here's our mass, 1,100 kilograms. And here's our acceleration, 4 meters per second squared. We multiply 1,100 times 4, and the answer is 4,400 newtons. And that makes sense because we have just multiplied kilograms times meters per second squared. And that's the unit of a newton. Easy peasy. Now, here's a question that came from a GED practice test. Oh, I didn't mean to give you all that. Let me back up. So, use Newton's second law to find the initial acceleration of an object with a mass of 42 kilograms when a force of 6 newtons is applied. For this problem, ignore direction and round to the nearest hundredth. So as an aside, when this says for this problem, ignore the direction and round to the nearest hundredth. Acceleration as a scientific term includes not only the magnitude or how fast you want the object to go, it also includes the direction. So that's what's called a vector. So it has a direction, and it's telling you to make this easy, we're going to ignore the direction. So just act like all we're concerned about is the speed of the object, the acceleration, and round to the nearest hundredth. Well, you know that's talking about your answer is going to have 2 numerals after the decimal point, because that would be the hundredths place. So use Newton's second law. We know that is formula for that is force equals mass times acceleration. We substitute in what we know. We know 42 kilograms. That's the mass. It tells us mass of 42 kilograms right there. We're going to substitute that in for mass. And then it tells us the force of 6 newtons. So we're going to put that in here for force. So 6 equals 42A. And how do we solve for A? We know that 42 and A are multiplied. So to isolate this variable and undo the multiplication, we're going to divide both sides by 42. 42 divided by 42 is 1, so that gives me 1A. And 6 divided by 42 is 0.14 or 1400. And the unit that we're going to use is 1400 meters per second squared. And that makes sense because we know that force is measured in kilograms times meters per second squared. We divided by the mass, which is kilograms. So kilograms divided by kilograms equals 1. And that leaves us with meters per second squared. Now, be careful, even though this seems unusual, that we're going to divide a smaller number by a greater number. That is what the math is telling us to do right here. So it's helpful to realize that acceleration can frequently be less than 1. And I know if I take a smaller number and divide it by a greater number, my answer will be less than 1. So do not just assume greater number divided by smaller number. Do what the math is telling you to do. Okay, and it did say round to the nearest hundredth, and our answer has 2 places after the decimal point, so we followed that direction. Here is another force problem. So Corey has a skateboard that he rides at Newton's skate park. That was that little joke this problem did, because Newton for Isaac Newton. At the top of his jump, the net force acting on him is 30 newtons, and his acceleration is 1/2 meters per second squared. What is the combined mass of Corey and his skateboard? So we know this is a force problem because right here it tells us force acting on him is 30 newtons, and it has an acceleration, and it's asking for the mass. So force equals mass times acceleration. There's our formula. We're going to substitute in what we know. We know the force, 30 newtons, and we know the acceleration. It's asking for the mass. So the mass is going to be our unknown. When we substitute in, it looks like this. 30 newtons equals my mass, whatever that is, or actually Corey's mass, times 1/2 meters per second squared. How do I find out what the mass is? I know that the mass is multiplied by the acceleration. So to undo this multiplication and have the variable remain by itself on this side, isolate my variable, I'm going to divide both sides by 1/2. So when I do this, what that looks like is my mass times 1/2 divided by 1. 1/2 divided by 1/2 equals 1. So I will have my variable by itself. Perfect. That's what I want. Then 30 divided by 1/2. Again, this is a little bit counterintuitive. When you divide by a number that's less than 1, what happens to that original number? It increases in size. How many halves are there in 30? Well, each one has 2 halves. So you have the greater number of 60. So there are 60 halves in 30. So the mass of Corey and his skateboard together are 60 kilograms. Looking at him makes me wish I could skateboard. I cannot. Okay, here's a new problem. A stopped speedboat increases its speed from a rate of 0 meters per second to a rate of 45 meters per second in 3 minutes. What is the boat's acceleration in meters per second squared? Well, the formula for acceleration, what he's asking for here, acceleration, is a change in velocity divided by the change in time. And velocity in this case, we're talking about its speed. It's a rate. We have 0 meters per second to a rate of 45 meters per second. We call that change in velocity over change in time. The way we determine that is to subtract the velocities, subtract the times, and then divide. So notice it says velocity 2 minus velocity 1. It doesn't matter actually which one you call velocity 1 and velocity 2, as long as you get the corresponding times correct. So let's see the way this would have us set it up. Velocity 2 would be its ending velocity. The ending velocity is 45 meters per second. And the starting velocity is 0 meters per second. So we're going to do ending velocity minus beginning velocity. And then we just have to make sure we get our times correct. 3 minutes. That's the time that corresponds to 45 seconds. So we're going to make sure that we get 3 here and 0 here. You know what? I think when I did this, I did it backwards. I did it the other way. We're going to find out it doesn't matter. You can do it either way as long as you correspond the correct velocities and time. Oh yeah, I did it the other way. I did starting minus ending and starting minus ending. Let's make sure that makes sense. When we finish that, we get the correct answer. Okay, 0 minus 45 is going to be negative 45, and 0 minus 180 is negative 180. So that looks like negative 45 minus 180, divided by negative 180. Now, when you divide a negative number by a negative number, the answer is positive. And again, if that's something that does not sound familiar to you, I know that there are recorded videos that you can look at talking about adding and subtracting and multiplying and dividing positive and negative numbers. But for right now, just remember that when you divide a negative number by a negative number, the answer is a positive number. So the answer is 0.25 or 2,500 meters per second squared. When I divide these seconds by these seconds, it's meters per second squared. Now, here's why this would have worked if we had done it the other way. If we substitute in for here, think about this. This would have been 45 minus 0 and 180 minus 0. That would have given us 45 over 180, and a positive divided by a positive is still a positive. And so we would have come out with 0.25, positive 0.25 meters per second squared. So the key is to make sure that you do either, as I did here, starting minus ending in the same order, or ending minus starting, ending minus starting. Either way, you'll come out with the correct answer. And that's the power of algebra. Math makes sense. Okay. So this problem says mechanical advantage is a measure of the force amplification that is achieved by using a tool, mechanical device, or machine system. The formula for mechanical advantage is the mechanical advantage equals the output force divided by the input force. Let's see if we can figure out what this is telling us. So mechanical advantage is a measure. Okay, so I'm measuring something. What is it? I'm measuring the force amplification. So amplify. I know that when I have amplifiers on my sound system, that makes the sound louder. So it makes it stronger. So I am doing something to increase the force that is achieved by using a tool, mechanical device, or machine system. That makes sense to me because I know that if I have a hammer, I can get much more force behind it than if I just press on something with my hand. If I have a knife, I can chop much better than if I am not using that. I get more force. If I have a piece of equipment like a backhoe, I can do much more work. So it's talking about strengthening the work that I can do, increasing the work that I can do with the tool. So in this case, let's see, what tool am I using? A crowbar can be used to remove a nail from a board. This is a crowbar, and this is what it's doing. It's helping you use leverage to pull that nail out. Think how hard that would be just to pull a nail with your hand. out of a piece of wood. But when you can get the leverage used by this crowbar, not to mention getting this piece of the crowbar underneath the nail head to pull it up, then you have made your work much easier. You've increased the force that you can use with this tool and increase the work that you've done. So it says a crowbar can be used to remove a nail from a board. If the crowbar has a mechanical advantage of 8 and the force of 40 newtons is applied to it, what will be the output force? My goodness, they've given me the formula right here. It told me that the mechanical advantage is 8, so I know I would substitute that in here. It's asking me what the output force is, so I know this is going to be my unknown. And it gives me the force of 40 newtons applied to it. So if I'm applying, that sounds like a synonym for input, something that I would use, that I would put into the system. Applying, that makes sense. So it looks to me like my equation would look like this. Mechanical advantage 8 equals the output force, which is my unknown, divided by the input force, which is 40 newtons. So I don't have enough space to work on that here, so I'm going to bring this up to my next page. 8 equals the output force, my unknown, divided by 40. Well, how do I solve this? How do I get this unknown output force by itself? I'm dividing it by 40. So to undo this division, I'm going to do the opposite. And the opposite of dividing by a number is multiplying by a number. So I'm going to multiply both sides of my equation by 40. And that looks like this. 40 times 8 equals my unknown here, times 40 divided by 40. If I divide 40 by 40, I get 1. So now I've got 1 of whatever this output force is, equal to 40 times 8. 40 times 8 is 320, and that equals my output force. And if I'm talking force, I know that my units are newtons. So 320 newtons. Now, if you did not know anything about mechanical advantage, or much of what this was talking about, or if you didn't have time on your test to really go through and figure this out, just take a deep breath and think, they've given me a formula, and I know that if I have some of these pieces, if I know some pieces of this formula, I can figure out the unknown and substitute and then solve. And that will help you be successful on the test. As I've looked at the science test, I know that many of the questions are not not formula questions. Many of them are logical questions. So if you can read the problem and think it through, you can get there. However, don't be put off by a formula question, because now you know how to do them. Thanks for joining me.